Hello, hello, can you hear me? Okay, let's see if this works. Hi, I'm Norbert. I'm the TPM of the Bridges team. It's my first time here, so thanks for having me. And if you hear my voice trembling, it's a feature, not a bug. So before diving in, by raise of hand, tell me if any of you were or are frustrated with the limitations of blockchain interoperability right now. Yeah, same. we share the same frustration. So currently, most blockchains are like isolated digital islands. They have their own rules, their own community, their own applications, but they lack effective means to communicate with each other. So Polkadot envisions a multi-chain universe, essentially an internet of blockchains. So Bridges will serve as a critical, let's say, conduit making this vision a reality, because a connected ecosystem will open doors for shared security, increased scalability, and asset transfers, and more. But we have to make sure that bridges share the same security as the blockchains themselves, because in this time and age where third parties collect fees and are like single points of failure, traditional centralized methods contradict the very essence of blockchain, so a trustless mechanism is the need of the hour. That's where trustless bridges come in. Trustless blockchain bridges is a decentralized mechanism that allows for the secure and seamless transfer of assets or data between two different blockchain networks without the need for intermediaries or centralized entities to facilitate the transaction. So in a trustless bridge, the architecture is designed in a way that each step in the process can be verified by the users of the node themselves. So making use of validators, relayer consensuses, cryptographic proofs, bridges will enable more complex applications and use cases while upholding security principles that are foundational to blockchain technology. Also, the Polkadot Kusama bridge is composed of a transport and a protocol layer, which we'll discuss later. Now let's move to XCM, which is the protocol created by us that enables cross-chain communication. It allows blockchains in or outside the Polkadot ecosystem to interact and share information or value without relying on centralized intermediaries. It's designed to work with parachains, parathreads, or different consensus blockchains, for example, the Snowbridge Ethereum that you will see today. So from simple asset transfers to complex multi-step operations, XCM supports a wide range of use cases. And what makes it even more brilliant is the fact that being a standardized message format, developers won't need to build custom solution for each pair of blockchains that they want to implement, thus reducing complexity and potential for errors. How do we manage all these bridges? With Bridge Hub. Bridge Hub is a system parachain, formerly known as Common Good Parachain, aka owned and controlled by not owned, controlled by governance, and is responsible for bridge operations. Follow the Polkadot vision, where the relay chain is all responsible for providing security to its parachains. We created this dedicated system parachain to host the bridges and all its pallets in the runtime, message queue pallet, grandpa pallet, beefy pallet, so on. So Bridge Hub is part of the infrastructure and will not be a user-facing point itself. And the bridges here are meant to be trustless, transparent transport for other parachains to build cross-consensus applications. OK, as I mentioned before, we have two layers for the Polkadot Kusama bridge, the transport layer and the DApp layers. The transport layer, it's low-level implementation with high security guarantees. Basically, the target chain relies on the relayer, the finality proofs, and the light client to know what is happening on the source chain. So the light client knows all the active validator set. It takes the blob of message. It verifies the signatures using the public keys. And if it's all correct, it imports the blockhead to the state of the target chain. And after it does that, it can use the storage proof to verify if the message exists at that specific location on the source chain. But I won't go too much more on details with this one. So although I mentioned message passing, it can transport any type of state, and it's transparent to users and even builders to some extent. Moving on, the second layer, the dApp layer, it's composed of cross-consensus XCM programs. So basically, the dApp layer knows it receives blobs of data and relies on the transport layer to verify if that data is trusted. And if that's the case, it will execute it. So XCM operates in a way that is indifferent to the rules of the blockchain it's connected. It's only dependent on XCM configs and XCVM capabilities. Also, it allows the transport protocol to not have any predefined or hard-coded use cases. And XCM itself can address and build a plethora of use cases that will be used on the bridge. So builders can use the bridge for their cross-consensus applications without requiring any special features. You just have to build with XCM. OK, now let's get into the Polkadot Kusama asset transfer case. This will be the use case that will come with the launch of the bridge. It will be already implemented. And this will also extend to manage USDC/USDT transfers in between Polkadot and Kusama, now that Kusama doesn't support anymore. So here we can see a high-level representation and the main actors, the asset hubs, the relay chains, the bridge hubs, and the relayer. Speaking of asset hubs, I won't go deeper into the use case without first touching on the foreign asset palette, which is a key component. So for cross-chain functionality, having a way to handle assets is crucial. So we also have created the foreign asset palette and added it to the asset hub, and allows us to represent assets from other chains, simplifying asset management. So the foreign assets are identified using multi-location. So basically, in the foreign asset palette, wrapped assets are pointing at the origin of the asset they are representing. So here we are in Polkadot.js on the foreign asset string. We are in the Kusama asset hub right now. And we want to create the wrap dot. So here we have parents, 2, which is like global consensus in the universe. Then we select interior X1, which is a relay chain. And then we select Polkadot. And what does this do? It creates a wrapped dot on the Kusama asset hub. Like to give a real-life example, for example, we're here. This is like the Kusama asset hub, and dot is, I don't know, the cafeteria. In order to do this, we go to the universe, which is the hallway, and then we say second door to the right. And that's where you find dot, and you can create a wrap dot. OK, now let's get into the full example and full presentation of the asset transfer from Polkadot Kusama. Now we are on the asset hub Polkadot. We need to execute an extrinsic, which is limited reserve transfer asset. We need to have a destination, beneficiary, and assets. Again, we are using here the multi-location to set up the destination, parents 2, and now we have a X2, which means we are going to a parachain, not to the relay chain. Global consensus, Kusama, and here is the idea of the parachain. It's like the previous example with the cafeteria. You're looking for the coffee machine. This is the coffee machine, parachain 1000. Then we have to select the beneficiary. This is somehow in rapport with what we chose there with the parachain 1000. And we have to select interior X1. We stay in the same place, the account ID, and this is where we send the assets. This is the beneficiary. Next, we have the assets. I hope you can all see clearly. I will move here. So the assets, we're doing it in relation with the place where we are now, on Asset Hub Polkadot. And now we select parents 1, which is Polkadot, here, and to select the token, the asset. and we select 30 dots to transfer. The fee asset item, like where the fees will be paid, it's from here, and the weight limit, it's unlimited. So when we send from Asset Hub Polkadot to Asset Hub Kusama, we don't, we don't have a limit for the weight calculation on the Bridge Hub Kusama and Asset Hub Kusama. It will send it no matter what. So here we will submit the transaction. You see here that we will pay a fee of 0.09 dots. This won't be taken from the amount transferred, but it will be taken from the sovereign account, from your account of dots. And the rest of it will be sent, like XCM accepted, transaction fee paid, and message sent. Now the message is going to Bridge Hub Polkadot. Reaching Bridge Hub Polkadot, it executes the export message instruction, identifies the bridge and lane to use based on destination, and holds the inner XCM message to the bridge. So first, Bridge Hub Kusama accepted. We have the lane ID here. And once we have that, then we are sending. We use the lane ID we received from Bridge Hub Kusama, and then we deliver the message. The message goes ahead to Bridge Hub Kusama, which imports incoming messages, verifies and confirms back, which you already saw, and dispatches the XCM message to its intended destination. So Asset Hub Kusama in this case. So here you see it received and dispatched, and the message sent. We get to Asset Hub Kusama. Here we execute the incoming XCM message. Wrap tokens, wrap dots are minted issued on the destination account. Here, this was the destination account, and execution fees on Asset Hub Kusama are paid from the wrap dots issued. So we sent 30 dots. We should have had 30 wrap dots on Asset Hub Kusama. But the account only received 28.5 because almost 1.5 were deducted in fees. So as a summary, it's a light, secure, trustless transport layer with a dApp on top that can build anything using XCM. And Polkadot Kusama will be launched with the asset transfer use case. This will be the first one, but XCM opens us to all the possibilities like governance over the bridge and so on. So being the fact that I'm just the technical project manager, I don't know like the super details of the code. Here you can see our timeline when we launch. And here is our thread on the Polkadot forum. Here you will see next week instructions on how to use the bridge and just do what I did, test it on your own. And you can ask any, let's say, super technical questions. But if you have any questions now, you can ask me and I could try to answer. Thank you. Nobody? I thought it was a weighted feature. Yeah, go ahead.
Yes, so this only works for pirate chains, right? This doesn't work like generically for any blockchain. So can you do Bitcoin, for example, with this?
So you said not only for parachains. I didn't go into detail because next after me, you'll have Vincent from Snowfork. He will present the Snow Bridge with Ethereum. So you will see the same usage of, not particularly the same, but the usage of Bridge Hub to connect Polkadot with Ethereum and build a trustless bridge, which is like a first. But I didn't want to spoil anything for him. Yeah?
Is the fee you paid percentage-based or flat? Let's say I send 30 DOT from Polkadot to Kusama, and the Kusama chain is under heavy load. Could I be charged like potentially?
So we will launch with dynamic fees based on like the weight of the messages and how full Bridge Hub is in order to not have any relayer or someone exploit and send like low-cost message and block everything. We'll have dynamic fees, not dynamic as in increases one after another, but we have some levels which if you reach, the fees will be increased for delivering that message. Anyone else? You there?
Can you tell us a little bit more about the relayer network between the bridge hubs?
the relayer network between the bridge hubs. So the relayers usually are externals that use a software or something, and they take the message, they deliver it, and then they are paid paid fees, like paid rewards, sorry.
So is that a centralized network, or how is it incentivized, and how many machines are there?
Sorry, can you speak a little bit louder?
Is that an incentivized network? And I'm just wondering how many machines are there?
Initially, I think it will be flat, but we are working now on a model that will incentivize better relayers. Like, I don't think I should say it, but in the future we're thinking to have like an open market and relayers can bid on, I will take these meshes for this fee and deliver it. But this is something that we're working on. Anyone else? No? OK, then thank you for having me. I hope you will use the bridge as soon as it's out. And hopefully see you next time. Thank you.